Hello guys, welcome to my YouTube channel Math Method. Today we will learn about the basic proportionality theorem, that is also called as Thale's theorem, in 6.2 exercise. So let's start with chapter exercise 6.2. Now question number 1, first part, that is the given figure is this: ABC is an right angle triangle and DE is parallel with BC. So in this figure, DE is parallel with BC. DE is parallel with BC, that is given to us. So BC, that is given. Now by the basic proportionality theorem, here implies AD by DB is equal to AE by EC. Clear? Now here AD by DB is equal to AE by EC, AE upon EC. This is called Thale's theorem. Thale's theorem, or you can write it as basic proportionality theorem or BPT. Clear? Implies here AD is given as 1.5 centimeter divided by DB is our 3 is equal to AE is our 1, and we have to find out the value of EC. So implies EC is equal to 3 into 1 divided by 1.5. This is our cross multiplication. 3 into 1 divided by 1.5 implies EC is equal to 3 upon 1 by 5. 1.5 is equal to 2 centimeter. This is our answer, part 1. Similarly for part number 2. Similarly in this figure 2, second figure, DE is again given as D is parallel with BC. Now given that DE is parallel with BC, this is our given. So again AD by DB is equal to AE upon EC. Clear? This is also called Thale's theorem. This is called Thale's theorem, that is AD by DB is equal to AE by EC. Here in this question we have to find out the value of AD. Now AD implies AD by DB is equal to our 7.2 is equal to AE is our 1.8 upon this is our 5.4 implies AD is equal to 7.2 into 1.8 divided by 5.4, that is 1.8 is divided with 5.4 is equal to 1 upon 3. Here 3 divided is 1 and 2.4 implies AD is equal to 2.4 semi. Clear? This is our answer. This is our answer of part 2 of question number 1. AD is equal to 2.4 semi. Clear? Now question number 2. E and F are points on the sides of PQ and PR. This is not our figure. We have to draw it separately, respectively of a triangle PQR. For each of the following cases, state whether EF is parallel with QR. This is the converse theorem of Thales. Clear? Now we have to find out whether EF is parallel with QR or not in 3 questions, part 1, 2 and 3. Clear? Here in part 1 of question number 2, given that PE is equal to is equal to 3.9 semi. P is equal to 3.9 centimeters. EQ is equal to 3 centimeters, and PF is equal to 3.6 semi, and FR is equal to 2.4 semi. This is our given data. Now we have to find out whether EF is parallel with QR. Now, according to theorem number 6.2, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Now, here we know that PE by EQ is equal to PF by FR if whether PE by EQ and PF by FR or PF upon FR are in same ratio or not. Now we have to find out PE by EQ is equal to P is equal to our 3.9 semi upon EQ is equal to our 3 semi. By dividing 3.9 by 3, we will get 1.3 semi. Similarly, again we have to find out PF upon FR. PF is given our 3.6 divided by FR is equal to our 2.4 semi, which is equal to 3 upon 2. Divide both numerator and denominator by 1.2. We will get 3 by 2, which is equal to 1.5 semi. Here it is clear that PE upon EQ is not equal to PF upon FR. So, if the corresponding sides are not in the same ratio, therefore EF is not parallel with QR. Now, EF side is not parallel to QR. This is our answer. Clear? Now see the second part. Part number 2. Here P is equal to 4 centimeters. P is equal to 4 semi. QE is equal to 4.5 semi. PF is equal to 8 semi, and RF EQ. So in part 2, PQ is equal to our 1.28, PR is equal to 2.56, PE is equal to 0.18 and PF is equal to 0.36 semi. Now QE is not given, so QE is equal to PQ minus PE. Now this is 0.18 divided by PQ is equal to our 1.28 minus P is equal to our 0.18 is equal to 0.18 upon 1.28 minus 0.18 is equal to 1.10. Both numerator and denominator have two digits after decimal places, so we can write it as 18 upon 110, which is equal to 9 upon 15, 55. So here P upon Q is equal to 9 by 55. Similarly, we have to find out PF upon FR. PF upon FR. PF upon FR is equal to, again FR is not given, so PF is equal to our 0.36 equal to PF upon FR is equal to PR minus FR. PR minus FR, PR minus PF, which is equal to PF is equal to our 0.36 upon PR is equal to 2.56 minus 0.36, clear, is equal to 2.56 minus 0.36, which is equal to 0.36 divided by 2.56 minus 0.36 is equal to 2.20, which is equal to, again both numerator and denominator are the decimal expansions, where after decimal places there are two numbers, two digits, therefore we can write it as 36 divided by 220, which is equal to 36 upon 220. Divide both numerator and denominator by 4. 4 9s are 36 upon 4 55. Here PE upon QU is equal to PF upon FR. Therefore here EF is parallel with QR. Clear? This is our answer. Now question number 3. In the figure 6.18, if LM is parallel with BC or CB and LN is parallel with CD, prove that AM upon AB is equal to AN upon AD. We have to find out from this figure 6.18. Now question number 3, solution. We have to prove it. Now proof. Here is our proof. What we have to prove? AM upon AB is equal to AN upon AD. Now in triangle ABC, given that LM is parallel with BC, LM is parallel with BC, therefore by the basic proportionality theorem or Thale's theorem, AM upon AB, AM upon MB is equal to AL upon LC. Therefore AM upon MB is equal to AL upon LC. This is our Thale's theorem or basic proportionality theorem. Clear? So again another triangle, that is in triangle A, C and D. ACD triangle, write it as equation number 1. ACD, again write AN upon ND is equal to AL upon LC. AN upon ND is equal to AL upon LC. This is our equation number 2. So this is again by the Thale's theorem or basic proportionality theorem. Now from equation 1 and 2, from 1 and 2 both RHS are equal, therefore LHS will be equal, implies AM upon MB is equal to AN upon ND. Now reverse it, implies MB upon AM is equal to ND upon AN. Make denominator to numerator and numerator to denominator both sides, LHS and RHS. Now add 1 to both sides, implies MB upon AM plus 1 is equal to ND by AN plus 1. There will be no change if we add 1 to both sides, LHS and RHS, implies here 1 is equal to 1 upon 1, so LCM of AM and 1 is AM. Now here MB plus AM is equal to, similar for RHS, AN common, AN is our LCM, then ND plus AN. Now MB plus AM is equal to our AB, implies MB plus AM is equal to AB upon AM is equal to ND plus AN. ND plus AN is equal to our AD upon AN. Clear? Now again make denominator into numerator and numerator to denominator, implies to both sides, LHS and RHS, AM upon AB is equal to AN upon AD. This is our, we have to prove AM by AB. This is proved, write it, proved. Clear? Question 3 is solved. Now question number 4. In figure 6.19, DE is parallel with AC and DE is parallel with AC and DF is parallel with AE. We have to prove BF upon FE is equal to BE upon EC. Clear? We have to prove BF upon FE is equal to BE upon EC. Now question number 4, solution. Solution is in triangle ABC. In triangle ABC, DE is parallel with AC. DE is parallel with AC is given. This is our given. So by the basic proportionality theorem, BE upon EC is equal to BD upon AD or DA, implies BE upon EC is equal to BD upon DA. This is our 1. This is by the Thale's theorem or basic proportionality theorem. Similarly, for in angle, in triangle ABE, again DF is parallel with AE. Now for triangle ABE, it is given that DF is parallel with AE. Now by applying the Thale's theorem, again BD upon DF is equal to BF upon FE. This is our 2. Now from 1 and 2, BD by DA is equal to B by EC and BD by DA is equal to BF by FE. So from 1 and 2 we will write BE upon EC is equal to BF upon FE. This is the question asked for BF by FE is equal to BE by EC. Now this is our proved. Clear? Now question number 5. In figure 6.20, DE is parallel with OQ and DF is parallel with OR. We have to show EF is parallel with QR. This is the question you have to solve. Now the solution is here given in this given figure. In this given figure, it is also given that DE is parallel with, here DE is parallel with OQ and similarly DF is parallel with OR. DF is parallel with OR. This is our given. Now we have PE upon EQ. PE upon EQ is equal to PD or DP upon DO. This is from if DE is parallel with OQ, then PE upon EQ is equal to DP upon DO. That is our one. And similarly, and another one is PF upon FR. PF upon FR is equal to PD upon DO or DP upon DO. This is our 2. Now from 1 and 2 equations, both RHS are same, therefore LHS will be same. PE upon EQ is equal to PF upon FR. Now we found that P by EQ is equal to PF upon FR. Now go to now in triangle whole PQR. Now we have proved that PE upon EQ is equal to PF upon FR. Therefore, for triangle PQR, PE upon EQ is equal to PF upon FR. So, therefore, by the converse of basic proportionality theorem or the converse of Thale's theorem, we got EF is parallel with third side, that is QR. This is our proved. Clear? Now question number 6. In figure 6.21, A, B, C are points on OP, OQ and OR respectively, such that AB is parallel with PQ and AC is parallel with PR. So we have to show that BC is parallel with QR. Given that two sides of triangles are parallel with each other, we have to prove the third side, which is BC, is parallel with QR. Now we have to solve it. Now in triangle PQO, in triangle PQO, given that AB is parallel with PQ, this is given. So according to Thale's theorem implies PA upon AO is equal to QB upon BO. QB upon BO. This is our Thale's theorem. And equation number 1. This equation number 1 is obtained from Thale's theorem. Now in triangle POR, again according to basic proportionality theorem or Thale's theorem, it is given that AC is parallel with PR. AC is parallel with PR implies PA upon AO is equal to PA upon AO is equal to OC RC upon CO, RC upon CO. This is our 2. 2 is obtained from again Thale's theorem. Now from 1 and 2. Now from 1 and 2 we get both LHS are same, therefore RHS will be same. QB upon BO is equal to RC upon CO. We got it from equation 1 and 2. Now go to in triangle QOR. We have in triangle QOR, QB by BO is equal to RC by CO. QB by BO is equal to RC by CO. We got it from equation 1 and 2. Implies for QOQR triangle BC will be parallel with QR, which we got it. We have to write it, proved, hence proved. Clear? Now why I wrote it BC upon QR? This is the converse theorem of Thales, that is theorem number 6.2. Clear? Now question number 7. Using theorem 6.1, prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisect the third side. Recall that you have proved it in class 9th. Do you remember it or forget it? Now we have to find out the third side, which the midpoint of the side of triangle parallel to another side bisect the third side. Now I have drawn the figure like this: ABC, which and P is the midpoint of AB. Now this is our, we will write the solution. Now it is given that in triangle ABC, P is the midpoint of AB. Now it is clear that PA is equal to PB or AP is equal to BP or PB. Clear? And also given that PQ is parallel with BC and PQ is parallel with BC, that is given. Now we have to prove that for in triangle ABC, it is given that PQ is parallel with BC, implies according to Thale's theorem or BPT, that is basic proportionality theorem, AP upon PB is equal to AQ upon QC. AQ upon QC. Clear? This is our 1. Again we know that AP is equal to BP, so implies AP by PB is equal to also AP. Now AP upon AP is equal to AQ upon QC, implies AQ upon QC is equal to AP divided by AP is equal to 1, implies if AQ by QC is equal to 1, implies AQ is equal to QC. So AQ is equal to QC, therefore Q is the midpoint of AC, implies Q is the midpoint of AC. Clear? This is proved. Now question number 8. Using theorem 6.2, that is the converse of Thale's theorem, prove that the line joining the midpoint of any two sides of a triangle is parallel to the third side. It is also done in class 9th. Now we will write it as, see the procedure of writing the proof of theorem. Now we have to write first given. What is given? Given that in triangle ABC, P and Q are midpoints of side AB and AC. AB and AC are sides respectively. This is our given, and we have to prove, means to prove. We have to prove here PQ is parallel with third side, that is BC. Now here construction is not needed, so directly we will write proof. Now it is given that P and Q are midpoints of P and Q are midpoints of AB and AC respectively. Clear? Now if P is the midpoint of AC, implies PA is equal to PB, and if Q is the midpoint of AC, implies QA is equal to QC. Clear? Implies, according to Thale's theorem, from if PA by PB, PA is equal to PB, then PA upon PB is equal to 1, because both are same. Therefore if we divide one by another, then we will get answer 1. This is our equation 1. Similarly, again QA upon QC is equal to, again this QA is equal to QC. Then if we will divide QA upon QC, both are equal, then we will get 1. This is our equation number 2. Now from 1 and 2 both RHS are equal, therefore LHS will be equal. Therefore PA upon PB is equal to QA or AQ upon QC. Therefore if we put this term in triangle PQR, PA upon PB is equal to AQ upon QC. Therefore we will get, implies, if PA by PB is equal to AQ by QC, then by the converse of basic proportionality theorem, PQ is parallel with BC. Proved. Clear? Now question number 9. ABCD is a trapezium in which AB is parallel with DC and its diagonals intersect each other at point O, so that AO upon BO is equal to CO upon DO. Now I have drawn this figure. ABCD is a parallelogram. Now our given that ABCD is a trapezium. ABCD is a trapezium where whose AB is parallel with CD set. Clear? And diagonals AC and BD intersect at point O. Clear? Now we have to prove, means to prove. To prove, what you have to prove? To prove that AO upon BO is equal to CO upon DO. Clear? Now here requires a construction. What you have to construct? You have to construct EO. Here draw EO which will be parallel with AB. Draw EO parallel with AB side. Clear? Which meets AD at E. Clear? Now proof. What is proof? In triangle ADB. In triangle ADB, we know that OE is parallel with AB. That is, we have drawn EO is parallel with AB. Now, according to Thale's theorem, DE upon EA, which will be equals to DO upon OB or BO. This is our one. We got it from Thale's theorem, that is basic proportionality theorem. As we know, AB is parallel with EO again, and it is given that AB is parallel with CD, that is given. Now therefore EO or OE is parallel with CD. Clear? Therefore now in triangle ADC, here in triangle ADC we got, in triangle ADC OE is parallel with DC or EO is parallel with CD. Therefore, putting Thale's theorem, we will get DE upon EA, DE upon EA is equal to CO upon OA or is equal to CO upon AO. This is our 2. Again we got from Thale's theorem. Clear? Now from equation 1 and 2, D here from 1 and 2 both have LHS same, therefore RHS will be same. Therefore RHS is equal to DO upon BO is equal to CO upon AO. Now transpose AO to LHS implies here AO is at denominator, it will go to numerator. Therefore AO upon BO is equal to here CO, and transpose DO to RHS, it will go to denominator, which is equal to DO. This is our proved. Clear? Question number 9 is solved. Now question number 10. Question number 10 is the diagonals of a quadrilateral ABCD intersect each other at the point O such that AO by BO is equal to CO by DO, so that ABCD is a trapezium. This is the converse proof of question number 9. Now given that ABCD, the diagonals of ABCD intersect each other at O. Now I have drawn this construction. we have to write solution. Solution is, first we have to write what is given to us. Given that quadrilateral ABCD was where O is the intersection of intersection point or intersection point of AC and BD diagonals. This is our given, and also given that and AO upon BO is equal to CO upon DO. This is our given. Now we have to prove. To prove ABCD is a trapezium. Now ABCD is a trapezium. Here comes the construction. I did the construction. What is EO? Join OE such that OE is parallel with B. Now draw OE such that OE is parallel with AB. This is my construction. Now we have to prove. Now in triangle DAB, EO is parallel with AB. EO is or OE is parallel with AB. Therefore, according to Thale's theorem, OB upon OC is equals to AE upon ED. This is our Thale's theorem. Clear? Now, sorry guys, this is my mistake. I have written it wrongly. Now we will write in triangle DAB. Clear? EO or OE is parallel with AB. Therefore, DE upon EA will be equals to DO upon OB. This is our equation 1. I have written it wrongly, so pardon me. Now we know that AO by OB is equal to CO by DO. Now implies we know that AO by BO equals to CO upon DO. Implies if DO will transpose to LHS, it become DO upon BO is equal to CO upon AO. Transpose DO and AO. Numerator will be denominator and denominator will be numerator. Now this is our equation 2. From equation 1 and 2, here DO by OB is equal to DE by A and DO by BO is equal to AO by OC. Implies from 1 and 2 we got AO. This is our 1. This is our 1 and 2. DO by DO. Now DE upon EA is equals to CO upon AO. Clear? Now according to converse of basic proportionality theorem, implies OE is parallel with CD. Now we know that OE is parallel with AB and OE is parallel with CD, therefore implies OE is parallel with AB is parallel with CD. We got it. Therefore AB is parallel with CD, implies if OE is parallel with AB is parallel with CD, we can write it as AB is parallel with CD. Therefore in a quadrilateral whose only one pair of opposite sides are parallel, so if in a quadrilateral whose only one pair of opposite sides are parallel, then the quadrilateral is said to be trapezium. Therefore ABCD is a trapezium, proved. Clear? Now we have completed exercise 6.2. Hope you will enjoy it. Please subscribe to my channel Math Method. Do share, do like and give me reply so that I can give you reply back. Thank you so much for watching. Bye.